So we've been given this equation over here where x is present and we need to find the product of all real values of x satisfying it. Now since x is present in the power, this is an exponential equation, and the best way to solve exponential equations is to implement logarithmic properties, and we know for a fact that we have to implement logarithmic properties because this is already in terms of logs, and because this is log to the base 5, right? We can take log to the base 5 on both sides and we can sort of cancel this thing off completely, just make this negative 16 using logarithmic properties. So if we take log to the base 5 on both sides, essentially what we're doing is we're just making this 16 times log x to the base 5 cubed minus 63 log x to the base 5 times log x to the base 5, because you know the identity log m raised to power n is equal to n log n, and this basically just equates to negative 16 times log 5 to the base 5, and you know that this is just 1, so this whole thing just becomes negative 16. Now we have log x to the base 5 as a common thing present over here, so what we can do is we can take log x to the base 5 and equate it to y. So we can rewrite this to form 16y cubed minus this will become 63y times this whole thing will just become y, and this will equate to negative 16. So now we'll distribute this term over here. This becomes 16y to the 4th power minus 63y squared, and this 16 we can bring over here, so plus 16 is equal to 0. So now what we can do is we can take y squared to be k, right? We've not assigned k yet, so we'll take k obviously, and this just becomes 16k squared minus 63k plus 16 equates to 0. So this becomes a quadratic. We can divide the whole thing by 4, so this becomes 4k squared minus 17k plus 4 equates to 0. To split the middle term, we can take what do we get, 16 and 17 itself, 16 and 1, yeah, we can take that. So 4k squared, this will become negative 16k minus k plus 4 equates to 0. So if we take 4k common, this just becomes k minus 4, right, k minus 4, and if we take minus 1 over here, this also becomes k minus 4 equates to 0. If k minus 4 is common, we can take 4k minus 1 as well, and this in turn just becomes 0. Now from this we found out that k has two values. K is basically 4, or k can also be, see 4k is equal to 1, so k can also be 1 over 4, right? And since we had assumed k to be y squared, that means y ka values would be square root of this, so root 4, which is basically plus or minus 2, or plus or minus root 1 over 4, which is just 1 over 2. So yk values are essentially just 2, negative 2, half, and negative half. 5 to the power of this would be equal to x, essentially, right? So if we're finding x, 5 to the power of all this is what we need to find. We need to take the product of that. So what we're basically finding is x equates to 5 square, or 5 raised to the power negative 2, or 5 raised to the power half, or 5 raised to the power negative half. And since we're finding the product, we're multiplying each term. So 5 square times 5 raised to the power negative 2 will come down, so 5 square multiplied by again 5 raised to the power half, and this will also come down, 5 raised to the power half, using exponential properties. All these terms cancel off with each other to form 1, and this becomes your final answer.